More than 9 decades of serving the nation. Central Board of Irrigation and Power.
Good morning, everyone.
Good morning, sir.
My name is Neeraj Kumar Gahlot, and I am presently working in Power Grid Corporation. And I am here to talk to you on this substation automation system. I have been assigned this topic. Actually, in the power sector, whenever you will work in transmission or distribution segment, or even in generation also, or in any other private industry that is related to electrical or electronics automation system, electrical or electronic system. So you will definitely, you have to encounter this topic. You have to meet, definitely you have to see these things that I am going to cover today. Because what is happening is this automation and digitization, these things is happening at a very fast speed. And what is happening that it is affecting many dimensions. How we work, what our skills have. Our skill pehle, is everyone comfortable with Hindi also, na?
Yes, sir.
Yes, sir.
Yeah. So how it is affecting our work and what skills we have. So in every industry, wherever you will go, so you will find this that there are some changes happening. कुछ ना कुछ change ऐसे हैं जो हो रहे हैं. Means like the things that like we use old relay and old contactors, timers in the old substation. Now what is happening? They are going to be replaced with intelligent device, IED, electronic devices. IED, these are called relays of every manufacturer like ABB, Siemens, GE. All these, they call it IED, intelligent electronic devices. So every industry is going to replace the old relay with this new IED. Even in private sector also, you will find an HMI, human machine interface. You will find workstations. So all these things we are going to cover here in substation automation. For SAS, in simple terms, the meaning is removing complex wiring schemes, old relays, old copper wires, cables from a substation, from electrical substation, because it's a substation automation. Okay, no? Automation of a substation. Be a transmission sector at high voltage or be at distribution level automation. So it's the automation of a substation, of a electrical substation. So all these old things are going to be removed and new intelligent devices are going to come that will communicate without cables, without copper cables. They are going to communicate either through Wi-Fi, let us say, or they are going to communicate through TCP/IP based protocol, or they are going to communicate through optical fiber. So all these things are coming. So old cables, we use 24 core cables, let us say, in old substation. Now they are going to be replaced with a new one fiber only, and one fiber is going to replace that 24 core cable. So cost is reducing, everything is reducing, and it's a simple thing also, and easy to trace faults. You can, because there are a lot of fault in a substation when you will work. Okay, na? We distribution sector, they have more problems actually. In high voltage transmission, we have less problems, but still faults are coming. So whenever you are going to work, so you will definitely need these things. I would like to say you can ask any question related to this topic in between the presentation also, or after the presentation, as you like. Okay, na?
Yes, sir.
So I am going to start with this presentation. I am going to switch over between 2-3 presentation I have. So for a better understanding of your from your perspective. So it's a collection of a hardware and software component that are used to monitor and control an electrical system, both locally and remotely. What is happening is that in a substation, now substations are going to be unmanned. Many power grid substations are unmanned. There is no operation people working there. Even in HVDC also, HVDC Rihandadri and HVDC Vindhyachal, these two are oldest HVDC in India. So these two HVDC from previous month, they have been operating from remote. So everything, whatever is there in a substation, it is going to be basically presented at remote site so that remotely operation can be done. So this is what is automation is. It's a collection of hardware and software component that will monitor and control an electrical system from local also and from remote also. Earlier, without SAS, we also used to monitor. We also used to control it. But things were very bulky. Like I said, things were very complex. Now things are very automated, simple, safe, secure with this automation scheme. And you can very easily handle the data also. Like some fault has happened. So you can see how much this, or how much wave this has traveled, fault has traveled, what is the distance of the fault. So all these things you can easily monitor and control also. In the old system, you cannot do it. It was very difficult to do it. So it uses high-speed as I said, it uses high-speed microprocessor-based computers and IEDs. These IEDs are installed in strategic locations for collection of system data of substation equipment. So I am going to show you like more tutorial kind of thing. I am going to switch over between these two so that you can have a better understanding of the basic of this topic. So you see here, this is a conventional substation. As I said, the old substation, this is the switch gear. Okay, na? Breakers, CT, CVT, LA, transformers, all, or even in GIS or HVDC, let us say. So this is a switch gear that is installed in at the field. ये यार्ड में इंस्टॉल होगा, आपका ब्रेकर इंस्टॉल है, ये सारे इक्विपमेंट यार्ड में है, all these switch gear. Now we from the control room we have to monitor it. Okay, na? NCC here is from remote. So what is happening, that what we need from the switch gear is the status, like breaker is closed or open.
Sir, what is this NCC?
NCC is National Control Center.
Okay, sir.
Like
Okay.
if you want to operate from remote, LCC is Local Control Center.
Okay, sir.
So if you want to operate it locally. So you have a switch gear, like all switch gear is here. What you want from the switch gear is the status of switch gear. आपको यहाँ से ऑपरेट करना है, you have to operate it from here. तो आपको पता होना चाहिए कि ब्रेकर लगा हुआ है कि खुला हुआ है. आपको पता होना चाहिए कि आइसोलेटर लगा है कि खुला है. Only then you can do operation. So you need status of this switch gear. You need alarm from this switch gear. Let us say SF6 gas in a breaker has become low, or in the valve cooling some pump has become faulty of HVDC system. So you need alarms, all alarms of this switch gear. Breaker is moving, like isolator is opening, all these alarms you need. Then measurement you need. Measurement, CT, CVT, all instrument transformer measurement you need. And you want to send commands. Command from NCC to here to open the breaker, or from LCC to here if you are operating this locally. So you need a command also. So all these things are going to be going to LCC. And then we have separate control panels. Very, like you have many panels in a relay room if you will go to old substation. Like we have Ballabgarh substation in power grid. That is a very old substation, but all of them have become automated. At Dadri also, in switchyard, they have in NTPC switchyard, they have not moved to SAS yet. So they have many panels, like control panel is separate, production panel is separate, measurement panel are separate. So a very strange kind of thing nowadays. So this is going separately, and these are going through copper cables. As you will move through the presentation, as I will move through the presentation, you will get to know better, more understanding how the signal were transmitted. So from the control production measurement panel, this is going to annunciation and marshalling kiosk panel. This is a relay room or the control room where operator is sitting. So this LCC is local control of this breaker. This is located in the yard only, in the field only, and here this is located at the control room. So from here, this annunciator and annunciation means the alarm are coming, hai na? This red color thing. Na? So annunciation panel means the panel in which alarms and events are coming. So from here, operator sit and check that this bay has an alarm. So he will go to yard, he will operate locally or from here also. Then if you want to send this data to NCC, National Control Center or Remote Control Center, like we have POSOCO, that is RLDC, Load Dispatch Center, Regional Load Dispatch Center are there. So if you want to send data to NLDC, RLDC, so RTU panel is there, Remote Terminal Unit. So all these status hard wiring you have to do through copper cables. Na, copper cable you have to lay from this panel to this panel from all separate panels. You see, so there are lot of thing in the conventional substation, and then through telecom signal you have to send this to data to an RLDC. Actually, this has various names depend on which country you are. So NCC, National Control Center. Somebody say it in India. We say it RLDC, Regional Load Dispatch Center. So we have 5 regional load dispatch centers. You might be aware. Okay, no? So one northern, eastern, western, and northeast, like that. So as I said, what system need from switchgear? Current signal from CTs, voltage signal from VTs, status from parts of switchgear. And what this switchgear needs? Command signal to operate parts of switchgear and alarms. Okay? You have to operate this breaker. The switchgear is needing command from the LCC or NCC. So this is showing a conventional type of. Then signal is distributed to all panel in parallel. So as I said, like you have to take the status of a circuit breaker to here. So what you will do? You have to have various contacts, various NONC contact. If you have little bit idea of this relays or conductors. So you have to have 4 or 5 NONC contact. From these NONC contact of a breaker, you have to hardwire to all, to LCC, to control panel, to protection panel, to measurement panel. Then again hardwiring is required through cables. So a lot of cable, and cable laying is a big task in the substation. Somehow you have to, we think like this, somehow how can we reduce the number of cable today? Today the thing is like that. 20 years before the thing was only through cables only. But now thing is that there are a lot of problems. You have many earth fault in the cables. So they have their life, and it's a bulky kind of thing. The signal distributed to all panel in parallel. So parallel means you have to have various contacts. So various cables are to be laid. So to all these cables you have to lay the cable. At this stage, system need to simplify this complicated circuit and display system status. Means the same thing, annunciation, marshalling, event record panel. So every panel you have to send in a convention. Finally, then signal convert to telecommunication and leave system to NCC. So through telecom, this signal is going to the remote for remote. Now in SAS, in substation automation system, how
Sir,
signal
sir, in the previous slide,
yes.
sir, the picture in which this person is standing, there are certain numbers written here, like 3000 and whatnot. So, what are these numbers?
What is happening is that, let us say, in a switch gear, You have to at NCC you have to see how many breaker operation, how many times breaker have been operated throughout its life cycle. So
Yes, sir.
yeah, so all this data is coming in this RTU panel,
Okay,
and then
sir.
whatever data is required here, like they require everything. Nowadays,
Okay.
RLDC, our load dispatch center, it
Yes, sir.
wants the complete status of breaker and isolator, earth switch, everything it wants at its screen here.
So this one is the real time.
Yes, this one is the real time. They
Okay,
see
sir.
it real time.
Okay, sir.
You know, they see it
Okay,
real
sir.
time there. Only then they can take decisions. If you will have some classes on load dispatch, I don't know. So you will get to know more about load dispatch center. But what they do, they have every data of substation, means all data of substation base, कि कितना पावर फ्लो उस लाइन पे, उस बे पे कितना पावर फ्लो चल रहा है, उस लाइन पे कितना पावर, HVDC में पावर फ्लो, everything they want. Only then they can control the grid, na? Because grid
Okay,
from
sir.
north to south, it is interconnected. All lines are connected in parallel. So only then they can take decisions. They have to take decision that how much generation is required, how much load we have to cut. All these things they have to take decision. So decision they can only take on the basis of real time information. Okay, na?
Yes, sir.
So that thing is there. In a SAS based substation, what is happening is this thing is same, this thing is same, LCC, because local cabinet will always be there with a breaker. Suppose some problem is there in the link, or in the cable has cut in the old system, or link has cut. So LCC is always present in every equipment. You will find that there is a local thing, and there is a button to operate that equipment in remote mode. This is available in every equipment: breaker, CT, CVT, HVDC pumps, HVDC valve hole. In every equipment, earthing, DC side, DC switches. In HVDC, we have lot of DC switches. So every equipment has a remote option and local option. So LCC is there. Okay. So in SAS based, what is happening? You see, protection, control, and metering is limited to very limited number of panels. What is there inside these panels is intelligent electronic devices, IEDs. They are electronic cards, electronic relays that have been designed by manufacturers like Hitachi, ABB, Siemens, GE, based on some specific IEC based protocols. So these things are there. So now all those parallel cables, you can imagine that from here you need 4 to 5 NONC contact. Now you need only one contact of this switch here, or for redundancy, let us say 2 contact only. So with this, lot of cabling has gone, lot of time, outage time in, and also tracing faults. Faults tracing is very important. Once a fault come, you have to trace it as fast as you can, especially in 400 kV system, where the availability is more than, power grid availability is more than 97-98% always. So you have to trace down the faults very fast, and you have to restore the system at the earliest. So that thing become easy. Now you will listen a buzzword, means the word that is going to come again and again in the industry in electronic thing, and you might be knowing also in BTEC, that IEC 61850 protocol. We will deal with this protocol. So this is a protocol to communicate. Okay? Communication of IED with communication panels. This is communication panel, means Ethernet switches will be there. Some firewalls will be there. I will show you more pictures of what is inside here. So this is getting communicated, and this is only a LAN link, Ethernet based link, or maybe a fiber based link, depend on the application of that. Depend on which manufacturer has supplied which kind of equipment. So अगर fiber का होगा तो you can connect through fiber, only one fiber cable, or LAN based also. If it is inside the substation, mostly it is LAN based. लेकिन आपको अगर थोड़ा डिस्टेंस से लाना है, like you have to take it from yard here, तो यहाँ पे आप फाइबर का इस्तेमाल करते हैं. Then communication panel to workstation. This is also one thing. Everywhere you will find in every industry, workstations, OWS, operator workstation, EWS, engineering workstation. So this workstation means now the thing that I have shown you here, this thing, annunciation and marshalling kiosk panel. There is nothing in the SAS like this. These panel are not there. They have been removed. Only one computer is there. Through LAN it is getting communicated. ये LAN से इससे communication panel से communicate कर रहा है. और ये सारा डाटा 61850 प्रोटोकॉल के थ्रू इस कंप्यूटर में इस स्क्रीन पे शो हो रहा है. Here you can, from this screen you can operate any breaker, any isolator, anything you can do. Whatever जो भी आपने इससे स्टेटस लिया होगा और जो आपने इसमें कॉन्फ़िगर किया होगा, so you can do anything from this computer only. So ये जितना एनुंशिएशन पैनल था ओल्ड स्कीम में, ये अभी भी है, बहुत पुराने सब स्टेशन में आप देखेंगे तो ये सारा हट जाएगा. की जगह ओनली वर्क स्टेशन विल. सेम थिंग इज if you want to send through NCC, it is also going to be sent through this 61850 protocol. So from this communication panel, you can operate locally in relay in control room, let us say, where operator will sit and operate this thing, or from NCC. NCC operator will send, the load dispatch center will send the command to operate this switchgear.